The topic of my deliberation is on Australopithecines. Most of all the Homo fossils of Africa, comparing with the African apes, has large brain, relatively reduced chewing or molar teeth, and limb bones that are, except in points of details, like those of modern Homo sapiens. However, there are at least 4 and 5 species of hominid that lack expanded brain, the reduced molar teeth, and the skeleton features of Homo. They antedate or overlap with earlier representative of Homo and are known as collectively as the Australopithecines. Raymond Dutt first discovered in 1924 at Tong in South Africa. The finding includes parts of mandible, facial skeleton, and endocranial parts of child. Dutt named the skull as Australopithecus Africanus. The meaning of Austral means south and Pithecus means ape. At first, discoverer of the various Australopithecines fossils named 4 to 5 genera, but now the consensus of scientific opinion recognize one genus Australopithecus and 2 species. A slenderly built and smaller form Australopithecus africanus, gracile form, and larger roughly built Australopithecus robustus, originally called Paranthropus. The following are the fossils along with the sites were found in South Africa and East Africa. Fossils of South Africa. In Tong, Australopithecus africanus was first discovered by Professor Raymond Dutt in 1925. In Komdrai, Paranthropus robustus was discovered by Robert Broom in 1938, and in Makapangut, Australopithecus promethicus was also discovered by Robert Broom in 1948. In Stankfontein and Swankern, Placentropus transvalensis and Paranthropus crescens were discovered by Robert Broom in the year 1936 and 1947. In South Africa, the gracile forms occur at 3 sites. They are Tong, Makapangut, and Stankfontein, and robust form at 2 sites. They are Komdrai and Swankerns. The fossils that are found in East Africa are in Ethiopia at 2 sites at Harder and Omo. At Harder, Australopithecus afarensis, which is also called as Lucy, was first discovered by Johansen in 1974. At Omo, Australopithecus africanus, Australopithecus boise, Homo habilis, and Homo erectus were excavated. In Kenya, in the site Kobifora, Australopithecus boise and Homo erectus were discovered. In Lotagam, Australopithecus africanus, and in Lake Turkana, Australopithecus boise, Homo habilis, and Homo erectus were discovered. In Tanzania, at Olduvai-Gos, Zinjanthropus boise was discovered in 1959, and Homo habilis, Homo erectus in 1964 by L.S.B. Leakey and his family Leakeys. And at Litoli, Australopithecus africanus was discovered. In East Africa, Louis Leakey in 1959 made the first discovery of a hominid fossils from bed 1 of Olduvai-Gos. The discovery first named Zinjanthropus boise, now known as Australopithecus boise, is considered to be a super robust Australopithecus. Another important discovery was announced in 1964 from Olduvai-Gos and named Homo habilis. Other important sites in East Africa are the Omo River Valley of southern Ethiopia, where both robust and gracile forms has been found. Similarly, both robust and gracile forms were discovered from Hadar in eastern Ethiopia and Turkana regions of northern Kenya. Turkana regions have been studied by Richard Leakey since 1969, and over 120 hominid fossils have been discovered so far. As the classification given by Lorenbos, hominidae is divided into 2 genus, Australopithecus and Homo. Australopithecus again divided into 2, Australopithecus africanus and Australopithecus robustus, of which Australopithecus africanus is divided again into two, Australopithecus afarensis and Homo habilis. Homo again, on the other hand, is divided into two, Homo erectus and Homo sapiens. Another classification given by John Robinson, he divided hominidae into two again, of which Australopithecus again subdivided into two, Australopithecus africanus and Australopithecus robustus, of which Australopithecus afarensis is included in Australopithecus africanus. On the other hand, he divided Homo again into three, into Homo habilis, Homo erectus and Homo sapiens. According to Loring Bruce, Homo habilis is a member of Australopithecus africanus, but in John Robinson it is not. The third classification given by Donald C. Jonassen, he divided hominidae again into two, Australopithecus and Homo. Australopithecus again divided into three, Australopithecus africanus, Australopithecus afarensis and Australopithecus robustus. T. Robinson dietary hypothesis. Going by the dental fossil evidence found in East and South Africa, there are two adaptive groups which can be extended to families. These two adaptive groups are gracile and robust. They are quite distinct in morphology, ecological relationship, and behavior. Gracile groups are Australopithecus and robust group are Paranthropus. He sees a dichotomy in craniodental form separating these two Australopithecine groups. Robust group has the post-canine teeth crown are large, canine thick, occlusion surface larger, root well developed, relatively flat occlusal surface, greater enamel has been damaged. Crowning and size reduction of the front teeth points to a primary dietary function of crushing and grinding. The massiveness of the entire masticatory apparatus, including the musculature and the wares of the teeth, indicate a diet of rough material which needed much chewing. Hence, robust was herbivorous or vegetarian. Gracile form shows none of these features, rather their post-canine teeth are smaller and anterior teeth would be substantial until tool making had reached a fairly advanced level. Age and antiquity of places. The Tong cave, once considered to be very ancient, actually seems to be the most recent one, less than 0.9 million years ago. The specimen may represent one of the last surviving members of the genus Australopithecus. The absence of suitable material precludes the use of radioactive dating in South Africa. A recent attempt of dating in South Africa on the basis of geological data has resulted the following dates: Makapansgat 3.7 million years, Stankfontein 3.3 million years, Swankern 2.6 million years, Tong 0.9 million years. In Olduvai prehistoric volcanic activities provided abundant material for the application of radioactive dating techniques. The Australopithecus remains are dated by potassium-argon method and placed between 1.9 and 1.1 million years. Site of the Omo Valley has been dated between 2.75 million and 2.5 million years. The harder material is dated between 3 to 3.5 million years and the Lake Turkana is around 3 to 1 million years. However, gracile Australopithecus from other sites of East Africa such as Middle Awas and Lothagam extend the age range of this group of fossils to 4 million years and beyond, perhaps to 5 million years. Characteristics of Australopithecus africanus. Skull. Taken as a whole, the skull is a combination of small brain case and large jaw. The brain case lacked high vertical forehead of Homo sapien and the high roundedness of the skull vault. This gives a simian appearance, but in bone feature it contrasts with pongidi and matches with hominidae. Number 1. The supraorbital height index shows that the relative height exceeds the range of variation in anthropoid apes and actually comes within the range of hominid skull. Number 2. The occipital torus and the inion occupy low level as in hominid skull. In adult apes, this occipital torus forms a crest high up the occipital aspects of the skull, thus extending considerably the nuchal area for attachment of neck muscles. In Australopithecus, the nuchal area is restricted as in Homo. Number 3. In Australopithecus, the occipital condyle are forward in position relative to the total length of the skull and the auditory aperture. The Pongidae, the occipital condyle are behind the midpoint of the cranial length and also behind the auditory aperture. Number 4. In all the Australopithecus skull in which mastoid regions are sufficiently well preserved, there is a well-marked pyramidal process typical of hominid form. Number 5. The brow ridges are poorly developed in compared to that of the apes. Number 6. The facial skeleton is however large in relation to the brain case. Number 7. The cranial bones of Australopithecus robustus are thicker than the Africanus and the sagittal crest is developed. The zygomatic arches are expanded and flared. The jaws are also relatively large but no simian self. Cranial capacity. In cranial capacity, the range of variation is quite considerable. The skulls of Australopithecus afarensis and Australopithecus africanus ranges from 400 to 500 cc and Australopithecus robustus ranges from 410 to 530 cc. Thus, the general endocranial size of Australopithecus does not differ markedly from those of gorilla and chimpanzee. However, in relation to the body size, Australopithecus show larger brain capacity proportion than the apes. Dentition. Australopithecus dentition is essentially of hominid type. In all the adult specimens, the dental arcade is evenly curved as in Homo sapien with no diastemic interval. The canine is reduced in size and spatulate in form. Canines and incisors are almost in the same level. The anterior upper premolar have two roots. The anterior lower premolar are non-sectorial and have one root. There is a good evidence for the studies of the immature specimen that the order of eruption of permanent teeth agrees with the hominidae. In Homo sapien, the canine erupt before the second molar. This is reversed in the apes. Pelvis. The total morphological pattern of the pelvis of Australopithecus is hominid. The anterior inferior iliac spine is strongly developed. The ilium is much relatively broader than in apes. The broad ilium lengthens the attachment of the gluteus muscles, important in maintaining balance of the trunk on the leg. The gluteus maximus becomes a fourfold extension muscle, part of the complex needed for erect bipedal locomotion, whereas in monkey and apes, the gluteus maximus is an abductor muscle. The posterior extremity of the iliac crest is extended backward and downward in the sacral area. The angle of the sciatic nodes is more acute in the pelvis of man and Australopithecus than that of the great apes. This is resulted in part due to the development of prominent scale spine. Scale tuberosity is relatively high in men and Australopithecus, closer to acetabulum than that of the apes. Sacrum is shifted outward and closer to the acetabulum, forming more or less a basin or funnel-shaped pelvis, which indicates the characters of erect posture. In all these characters, the pelvic bone of Australopithecus contrasts with the apes and shows pattern for erect bipedalism. However, the pelvis of Australopithecus is not fully developed like that of the modern man. Skull tuberosity is not as quite closely approximated to the acetabulum as it is in Homo sapien. The anterior superior spine extended further forward. The limb bones. In addition to the pelvis, the Australopithecus finds include many fossilized bones of leg, hand and feet. One group from Australopithecus include 12 of the major bones of a single foot so perfectly preserved that the details of the foot are readily reconstructible. The foot of Australopithecus is much smaller than the human foot, but the metatarsals are hominid and the big toe points forward, not sply out. The carpus bone and the phalanges found in Australopithecus also show hominid characters. Two specimens of the lower part of femur found at Stanfontein have been described. They show a combination of features such as the obliquity of the shaft, the alignment of the condyles, the forward prolongation of the intercondyle notches, which confirm to the hominid femur. Upper extremity of one specimen, however, shows certain pongidity features, such as relatively small size of the articular head. A tibia and fibula found in Olduvai have relatively straight shaft conforming to hominid characters. Difference between Australopithecus africanus and Australopithecus robustus. Character. Height. The height of Australopithecus africanus ranges from 1.1 to 1.5 meters. Australopithecus robustus ranges from 1.2 to 1.4 meters. Weight 30 to 60 kg, 40 to 80 kg. Physics. Light build, probably relatively long arms, more human features, probably less sexual dimorphism. In case of Australopithecus robustus, very heavy build, relatively long arm, marked sexual dimorphism. In case of brain, the brain size ranges from 400 to 500 cc in Australopithecus africanus, and in Australopithecus robustus it ranges from 410 to 530 cc. Skull form. Low flat forehead, shorter face, brow ridges less prominent in case of africanus, and in case of robustus, prominent crest on top and back of skull, long broad flattish face, strong facial bruising. In the characters of jaw teeth, in Australopithecus africanus, it have small incisor like canine, no gap between upper incisor and canines, larger molars. Whereas in Australopithecus robustus, it has very thick jaw, small incisors and canine, large molar like premolar, very large molar. Phylogenetic position. Currently, there are three main phylogenetic trees, each with its own cadre of proponent. Figure A, given by Johansson and White. This phylogenetic tree places Australopithecus afarensis II as ancestral to the later Australopithecine on one hand and the Homo line on the other. It gives Homo line a late start, that is after 2 million years. Figure B, given by L.S.B. Leakey. The common ancestors of Homo lineage and Australopithecine lineage diverge quite early, and certainly by that time Australopithecus afarensis was on the scene. So, Australopithecus afarensis is not the common ancestors of Homo and Australopithecus. The figure C is the combination of A and B, where Australopithecus afarensis is accepted as being ancestral to Australopithecus africanus, and it gives rise to the Homo line on the one hand and another to Australopithecus robustus on the other. Here, Australopithecus africanus may have been a transitional form which lead to the emergence of Homo habilis. Problems. The problem is whether Australopithecus africanus represent early grade in the Homo lineage, or it was a small-brained hominid arising as a separate product of Ramapithecus radiation. For the moment, the above problems still await resolution, because we also do not know whether the relatively range of size and morphology in these early fossils material merely reflect the polytypic nature of single taxon, or where is systematic enough to conceive of two taxa, one gracile-bodied and the other larger-bodied, with the latter more small jaws being due to allomatic effect rather than profound dietary differences. There is no generally accepted phylogenetic tree for human evolution. There are several proposed branching, A, B, and C. Perhaps the major distinction between them is whether Homo is perceived as late arrival, as in the case of A and C, or as early arrival, as in B and D. In some phylogenetic, robust is considered to be on the same evolutionary line with Australopithecine, and some consider robust to be separated from the earlier gracile species. D, in which Paranthropus robustus promethicus is equivalent to Australopithecus robustus and Homo africanus equivalent to Australopithecus africanus. A third point to note is whether Australopithecus africanus is ancestral to Homo C and D, or is a side issue A and B.